The James Webb Space Telescope has discovered something truly extraordinary. Beams of light that appear to radiate from an urban center, shining from a location 4 light-years away. This discovery has sparked renewed interest in the possibility that there might be life on other planets. The telescope directed its focus toward Proxima Centauri b, the nearest exoplanet to our solar system, and observed oddly brilliant flashes of light. Could these signals be the remains of an alien civilization? Stay tuned for more developments. For years, both scientists and everyday people have been captivated by the idea of life beyond Earth. Any evidence hinting at the presence of life in outer space has been met with great enthusiasm. However, a pivotal moment came when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the universe. While scanning the depths of space, this powerful telescope discovered something extraordinary on an exoplanet located far away. It detected lights that resembled those from extraterrestrial cities, raising the possibility that an alien metropolis might exist on that distant planet. This idea has generated significant curiosity and excitement within the scientific community, as it could be the long-awaited breakthrough. Anticipatory in nature, this discovery suggests the existence of intelligent beings operating civilizations in ways we are only beginning to investigate. The lights, resembling those of a large city, were detected on Proxima Centauri b, located 4 light-years away. Engineers are amazed and perplexed. How long might they have been visible in space, waiting for our technology to advance to the point where we could detect them? David Kipping, an astronomer at Columbia University, has described the planet where these lights were discovered as particularly intricate. Unlike the majority of rocky planets, which absorb sunlight and infrared radiation behavior on this exoplanet is different because of its unique relationship with its host star, Proxima Centauri. This discovery made by the James Webb Space Telescope underscores the telescope's critical role. Its ability to capture infrared wavelengths was essential in identifying the unusual behavior of Proxima Centauri b, which is crucial for understanding the planet's atmospheric conditions. Researchers are planning to continue using the telescope to investigate this planet's atmosphere in more detail, hoping to determine whether it might be habitable. The James Webb Space Telescope has a high sensitivity to infrared light, enabling it to observe what happens on Proxima Centauri b even during the night. Many telescopes struggle to detect faint light in the vast darkness of space, but the Webb telescope excels at recognizing even the tiniest glimmers. This makes it an ideal tool to confirm whether the alleged city lights on the dark side of Proxima b are indeed real. Artificial light can be detected by a telescope in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b's interaction with its star heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it experiences day and night cycles much like Earth. The planet undergoes scorching heat during the day and cooler temperatures at night. The range of temperatures on Proxima Centauri b is largely due to its composition. For instance, if the planet lacks an atmosphere, the temperature difference between day and night would be extreme, cold on one side, hot on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides useful information about the planet's atmosphere. With its ability to image in the infrared spectrum, the James Webb Space Telescope can effectively examine the thermal emissions from the planet, offering insights into its atmospheric characteristics. Interestingly, the telescope orbits Earth in conjunction with the orbital period of Proxima Centauri b, enabling scientists to make detailed observations of its daylight cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine whether it could support life. Detecting substances such as oxygen, water vapor, and methane would suggest the planet's potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a complex process. While the James Webb Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other tasks. Its expertise lies in the investigation of concentrations of water vapor, carbon dioxide, and methane, but it is less adept at detecting free oxygen, a crucial sign of life. Nonetheless, the telescope can search for other key indicators like ozone, which signals a healthy atmosphere. As scientists examine the data gathered from the James Webb Space Telescope, the hunt for distant worlds continues. The search is bringing us ever closer to answering the question of whether we are alone in the universe. It is important to note that the James Webb Space Telescope can only observe a certain number of exoplanets closest to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope (ELT), which is set to begin operations in 2028. The ELT is designed to offer a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more specific data regarding their capacity to sustain life. Scientists are eagerly awaiting the launch of upcoming spacecraft and telescopes like the ELT. In the meantime, the James Webb Telescope continues to be an invaluable instrument for locating distant exoplanets. Despite its limitations, the Webb Telescope continues to provide important information that could alter our understanding of what lies beyond our solar system. Both now and in the future, researchers have ambitious plans for new space telescopes. They aim to develop methods that can block starlight interference, allowing for better observation of surrounding planets. This technique is similar to blocking the sun with your hand to see more clearly. The capability of these forthcoming telescopes to focus on the dim light reflected by exoplanets will make it easier to analyze their atmospheres and assess whether they may be able to sustain life. However, this is not an easy task. Stars are extremely bright, frequently outshining the planets around them. Because of this brightness, it is difficult to detect the planet's faint reflected light, which is essential for studying their characteristics. To address this problem, scientists are trying to develop several novel strategies. One such method involves the use of coronagraphs. These devices are placed inside telescopes to block out starlight while allowing the planet's light to pass through. By meticulously shaping the light waves, coronagraphs can significantly reduce the brightness from the star, facilitating the detection of the dim light from exoplanets. Another promising approach is the starshade, a massive, flower-shaped spacecraft that will fly in formation with a telescope positioned tens of thousands of kilometers away. The starshade blocks light from the stars before it reaches the telescope, allowing only light from exoplanets to reach the instruments. This technique could be particularly effective for observing planets within the habitable zone of their stars, where liquid water and possibly life could exist. However, these advanced technologies necessitate extraordinary precision. For instance, the alignment of a starshade must be accurate to fractions of a millimeter over vast distances. In addition, these innovations must overcome the restrictions imposed by space missions, including the need for miniaturization, efficient energy use, and the ability to withstand the harsh conditions of space. Despite these challenges, the potential rewards are enormous. Successfully observing and studying the environments of exoplanets could lead to the detection of biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor in specific proportions. These molecules might indicate biological processes, suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which correct for distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper images. Combined with starlight blocking technologies, these advancements could allow scientists not only to detect exoplanets but also to map their surfaces and investigate their climates. The development of next-generation space telescopes represents a significant step forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By enhancing our ability to observe these distant planets, we are getting closer to discovering whether life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. The future of space exploration and the search for life beyond Earth is advancing at an unprecedented pace. As astronomers and scientists delve deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we edge closer to answering the ultimate question: Does life exist beyond our planet? The discovery of Proxima Centauri b, the closest exoplanet to our solar system, is only the beginning of what could be a significant turning point in extraterrestrial research. Proxima Centauri has been the subject of extensive study for years, but until now, finding concrete evidence of life, such as artificial light or signs of civilization, was merely a dream for many scientists. The fact that such light has been detected by the Webb telescope only increases the possibility that one day, we may contact other intelligent life forms in the universe. This discovery fuels both scientific curiosity and public imagination, encouraging new generations to consider what lies beyond Earth's borders. As the James Webb Space Telescope continues its observations, it is not only searching for artificial lights but also analyzing planetary atmospheres, their chemical compositions, and how these factors may support life. The search for biosignatures, such as methane or carbon dioxide in the right concentrations, is essential for determining whether these planets have conditions suitable for life. The Webb telescope has the ability to analyze these atmospheric components unlike any other telescope before it, highlighting the potential of distant worlds to support life. One of the most fascinating aspects of Proxima Centauri b is its location within the habitable zone of its star, where conditions could be right for liquid water to exist on its surface. The habitable zone is the region around a star where temperatures are neither too hot nor too cold for liquid water to form, a critical factor in determining whether a planet could harbor life. Discovering an exoplanet in the habitable zone makes it a key target for future missions. In addition to finding life-supporting planets, future space telescopes will also focus on the complex interactions between exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, meaning one side always faces the star while the other remains in darkness. This can create extreme temperature differences, which would significantly impact the planet's climate and its ability to sustain life. Understanding these conditions is crucial for astronomers as they assess the habitability of exoplanets. The growth of technologies that can block out bright starlight is another crucial advancement in space exploration. Without the ability to isolate starlight, it would be nearly impossible to detect the faint glimmers of light reflected from distant planets. The star shade and coronagraph technologies mentioned earlier are prime examples of how scientists are overcoming this challenge. By blocking out the overwhelming brightness of a star, these instruments enable telescopes to detect the faint light reflected by planets, offering crucial insights into their surfaces, climates, and potential for life. An exciting new development in this field is the use of advanced adaptive optics and starlight prevention techniques to explore exoplanets. Astronomers hope to capture high-resolution images of planets as they orbit their stars. These images would not only provide more detailed information about a planet's composition and atmosphere but could also reveal surface features such as oceans, continents, or weather patterns. This type of imaging would be a significant leap forward in our ability to study exoplanets and determine their potential to sustain life. As we continue to explore the universe and search for answers about the existence of life beyond Earth, the James Webb Space Telescope and future missions will play an indispensable role. Its ability to detect faint signals from distant planets, analyze their environments, and investigate their habitability is transforming our understanding of the cosmos. With advancements in technology and an ever-growing body of research, we are on the brink of discoveries that could reshape our knowledge of life in the universe.